Hi everyone, good evening. My name is Faizan and we are back with another video today which I'm recording for the topic which was the earlier part of this algebra top series. So it's quadratic equations and this is the second lecture that I'm recording today. So in this second lecture of quadratic equation, we will continue from what we had earlier done. So just a quick recap. In the earlier class, what we had done was we had done some basic ideas and we discussed some general format of equation, which is ax squared plus bx plus c, right? Now, ax squared plus bx plus c is something which is very standard format, and you must really know this. Ax squared plus bx plus c. So we'll further delve into this idea, and in my mind, what I have is we can cover roots. And before roots, we'll see some more examples and questions. So as a concept in this session, I'll try to cover roots and maybe some questions as well, which are covering the idea of quadratic, right? So we'll get started with the first question. All right, so the first question which I want to discuss is something about solutions. So what do we know about solutions? For example, if we have something like x plus y is equals to 100. So if I ask you that x and y, people tell you that x and y are integers, or I would say positive integers. So x and y are positive integers, and the sum of x and y has to be 100. So what I will now go on to do is that I will have to substitute values. So for instance, if I put x is equals to 1, if I put x is equals to 1, what happens is that I can get a value for y, which is y is equals to 99. Similarly, if I put x is equals to 2, I can get another value for y, which is y is equals to 98. And this will go on and you will get multiple pairs of x and y, which will be an answer to the question. So for example, if we have like x is equals to 2, then we will have y is equals to 98. If we have x is equals to 3, then we'll have y is equals to 97 and so on. So basically this way you are able to solve this question and you will get basically you will, because we don't have 0, you will get 99 pairs of solution, 99 pairs of x and y. Okay, so 99 pairs of x and y, and this means that if x is starting from 1, it goes on to 99, and then therefore you have different values of y. But remember, these are all positive integers. That is how you are able to solve for solution, right? Now, if I add in the same question, if I just add a small coefficient, for example, if I add a coefficient like twice of x plus y is equals to 100, right? Twice of x, which means that this is not simple x, but I've added a 2. In this case, there will be one small change, which is that now you can still have a x is equals to 1, but in case of y, this is not going to be 1. It is actually going to be 98, because as you can use your common sense, twice into 1 will give you 2, but because this is 2, y has to be 98. And similarly, if x is equals to 2, right? That means twice into 2, that will be equal to 4, and therefore in that case, y is equals to 96. And then you go on with this idea, which is that you put x value of x as 3, 4, 5, 6, and so on. And you go on to do this till x is equals to not 50, but 49. Because yes, because 50 will mean when x is equals to 49, then y will be equal to 2. And the value of your summation of x and y will be equal to 100. So you have to be careful on this. You have to be careful in the sense that you cannot put x is equals to 50. So in this case, because of that small change of adding a coefficient here, what has happened is that the value of x, or the pairs of x and y, are now going from 1, uh, 2, 3, 4 up to 49, right? So basically then the pairs that you now have pairs that you now have is what? Is actually 49 pairs. So the answer for this is therefore going to be 49 pairs, right? 49 pairs. Okay, one more question, which is on continuation on the similar lines. So if you have x plus y and plus z, what has happened is that now I've added one more variable. So instead of just x plus y, I've had one more variable. So this becomes x plus y plus z is equals to 100. And the same condition still applies, which is x, y, and z are all positive integers. Same condition. All right. So if it is again same condition and x plus y plus z is equals to 100, what I can do is I can start with the first one, which is if you put x equals to 1, if you put x equals to 1, and then what happens is that y plus z is 99. Okay. So now this y plus z becomes a question which we just did earlier. It becomes a question of two variables. So this itself is going to have 98 pairs of solutions, right? And this is just a solution when the condition was x is equals to 1, right? So notice this. This, when we put x equals to 1, it means y plus z has to be 99. And if y plus z has to be 99, that means that this will have 98 pairs. That means for every x equals to 1, you have 98 pairs. The same will be true when x equals to 2. The same will be true when x equals to 2. And when you have x equals to 2, the question now becomes y plus z is equals to 98. And if you have y plus z is equals to 98, the number of pairs of y and z which are going to be a solution for this is now going to be not 98, but it is going to be 97. And same process will apply. The process is actually more important. So the same process applies, which is put values of x as 1 and see what is the value of z, and so on. You continue doing this till you get the answer. So we discussed three questions, and all of these questions were about figuring out basically the pairs of different variables. And the way you do it is you put some number and see how what is the value that you get in terms of pairs. Okay, so this is a precursor. We'll now get into understanding the idea about this is known as a discriminant. Is equals to b square minus 4ac. So what is d is equals to b square minus what? Official term for this is discriminant, and this is something that is widely used. This is discriminant. So yeah. So this is what this discriminant b square minus 4. So now you'll be wondering what is this b and a and c, right? So discriminant is given by this formula, which is b square minus 4ac, but this b and a and c are determined from the general format. The general format of equation was ax square plus bx plus c. So take a moment, have a look at this, and please note it down. And what happens is that discriminant is equals to b square minus 4ac. I will now give you a question where you will have to compare the values of a, b, c and figure out what is the discriminant, right? So let us see one question. And what I'm going to do is I'm giving you one quadratic question, and you have to figure out the discriminant. All right, so let us see one quick question. The question is 2x square plus 6x plus some number, let's say 5 is equals to 0, right? Now compare it with the general format. If you compare it with the general format, you will get the value of A as what? As equals to 2. You will get the value of B as what? As equals to 6. and you will get the value of C as equals to 5. All right, so if you have gotten the values of A, B, and C, I can now figure out the value of discriminant, which is B square minus 4 into A into C. For this, what you will have to do is we'll have to do 36, which is B square, minus 4 into 2 into 5, right? And when you do this, what happens is that you get 36 minus 4 into 2 into 5, which is nothing but 36 minus 40, and as a result, you can say that the discriminant you have is actually a negative discriminant, which means we'll see how to interpret a negative discriminant. We'll see how to interpret a positive discriminant, and we'll also see how to interpret a neutral discriminant, right? So usually what happens is that if you have a negative discriminant, it tells you that the roots are not rational, the roots are complex. So which means that you do not have real roots. And that's the basic idea when it comes to discriminant, right? Let me give you one more question where we'll figure out the discriminant. The question is x square plus 6x plus 9, right? So if it is x square plus 6x plus 9, what I can do is I can do b square minus 4ac. Now, if I do b square minus 4ac, it would mean that I can look at the general format of this x square plus 6x plus 9, figure out the values of a, b, and c, and then put it over here. You get 36 minus 4 into 1 into 9. Okay. And this, when you are able to solve this, the answer that you get is a value of 0. So this is the exact case where the discriminant is 0. And it's also beautiful because if the discriminant is 0, it tells you something about the roots. And what it tells you is that the roots are repetitive in nature. The roots are repetitive in nature, right? It tells you that the roots are repetitive. They are repeating, repetitive in nature. They are repetitive in nature. In this case, you can also think of this case from the point of view of a plus b whole square. And if you do that, you will see that this will become x plus 3 whole square, which means that for an equation where for an equation where you have x plus 3 whole square, what it means is that you would be able to figure out that the value of x plus 3 whole square is equals to 0, means x must be equals to minus 3. And if x is equals to minus 3, then it means that that is a root. And it also means that that root x equals to that root x equals to minus 3 will be repeating in nature because it is x plus 3 whole square, right? So that's the wonderful idea. And finally, the third case where discriminant must be positive in nature. So it's nothing but I'll give you very simple example. If you have let's say x square and then plus 8x plus 15, right? Yeah, 15. We'll solve this quadratic equation. Again, try and compare this with ax squared plus bx plus c, which means that you have got your a as equals to 1, you've got your b as equals to 8, you've got your a as equals to 1, you've got your b as equals to 8, and you've got your c as equals to 15, right? C is equals to 15. Now, if you have A is equals to 1, B is equals to 8, and C is equals to 15, what you can do is you can use the formula for discriminant. And the formula for discriminant is B square minus 4AC, as I have discussed earlier. When you use the formula for discriminant, which is B square minus 4AC, what goes on to happen is you figure out that this is 8 square, and this is 4 into 1 into 15, 4 into 1 into 15. And as a result, when you are able to solve this, you will get a positive discriminant. All right, so we were talking about discriminants, and when it comes to discriminants, you will see that it can be positive, like this one was a positive discriminant, or it could also be It could also be a discriminant, which is the value of which is zero, which was the case in this problem. The value of discriminant was zero, or it could be negative. So you can have all these three scenarios. So this in turn, we call it D. This in turn will give you the idea about the nature of roots. So if it is positive, it means that the roots are what the if it is positive, the roots are real and distinct. So real as well as distinct. So another 15 minutes in this video, and then we will probably try and end this. So roots are real and distinct. If it is zero, then the roots are basically repetitive in nature. So they are just one root, and that's why repetitive in nature. Real, yes, but repetitive. And in case it is negative, in that case, the root is basically not real. We call it imaginary. In case, right? In case it happens that you do not have a positive discriminant, or you do not have negative discriminant. What we call in that case is that the roots are imaginary. So these three cases are the most important cases. It's very important to be very, very familiar and very, very comfortable with the idea of discriminant and understanding or concluding about the nature of roots from this idea of discriminants. Wonderful. So now what I'm going to do is I'm going to talk about the idea that this nature of roots, what is this root that we talk about so frequently? So one idea is that you can say that, hey, you talked about x a plus b whole square, those ideas, right? X plus 2 whole square or x plus 3 whole square. So one idea is that what you actually do is you tell that if I equate such expressions, which are a plus b whole square, if I equate such expressions, then the value of or the root that I get will be nothing but, in this case, for example, the root I get is x equals to minus 2. So one idea is this, that we equate whatever quadratic expression we get and we figure out what is the value of x. So that is what the definition of root is. In the case where the expressions are not so easy to understand, there is a method of figuring out what the roots are. So this is one of the expressions that I have discussed in the earlier board work that I've done. So this will mean that you can rationalize this as x plus 3 into x plus 5. Uh, this is something that you have to figure out, learn on your own. It's like thing that you will have to spend time. So x plus 3 is one like distinct expression. X plus 5 is another distinct expression. And when you are able to have these two distinct expressions and you sort of open the brackets and you multiply, what you end up getting is x squared plus 5x plus 15, right? Now, imagine that if this was to be equal to 0, that would mean that any factor, whether it is x plus 3 as a factor, or whether it is x plus 5 as a factor, right? If any of these factors are equal to 0, then you can tell the value of x. For example, in this case, you can take the value, tell the value of x as minus 3. Or in this case, you can tell the example of x as equals to minus 5. So these numbers that we have got here, which is x is equals to minus 3, x is equals to minus 5, these are essentially your roots. And in this case, x equals to minus 3, x equals to minus 5, these roots that you have are nothing but real numbers, and they are distinct real numbers. And if you want to verify it with discriminant, you will end up getting a discriminant which is actually positive in nature. if you want to verify with discriminants as well, you'll end up getting a discriminant which is positive in nature, right? So that is the idea that I was going to talk about. You have an expression, you can figure out the root, and this is what the root is. But in some cases, which we need to understand that there could not be an easy way to make these factors, right? These factors that I've made was easy in this example, but in some examples, it is not going to be easy. For example, if I walk you through one question, this is an expression x squared plus 6x plus 10. I wanted to pause the video and see if you're able to figure out the root of this equation. Remember, there would be two roots. If the discriminant is positive, there should be two real and unequal roots. X squared plus 6x plus 10, right? All right, so let me give you an idea. There is a formula for finding out the roots. There is a direct formula for finding out the roots. And the formula is again like this. It's minus b plus minus b square plus minus b square minus 4ac upon 2a. Now, if you look at this formula, there are certain terms like there's a term called b, there's a term called a, and there's a term called c, which means that you got to go back to the expression, which is ax square plus bx plus c. All right, friends, so we have got this beautiful expression x square plus 6x plus 10. And if you look at this expression x square plus 6x plus 10, I'm going to compare it with the general form of quadratic ax square plus bx plus c. And when you compare it with the general format of quadratic ax square plus bx plus c, what you're going to get is the value of a, b, and c. So and that is what I've written for you. I've written for you the value of a, which is equals to 1. I have written for you the value of b, which is equals to 6, and the value of c, which is equals to 10. Now, if you want to put it into the formula, you will end up getting the root. So let's put it over in the formula. So minus b minus 6 is what I'll write, plus minus, what is b square? B square is 6 into 6, 36. And what is a and c? 4 into 1 into 10. Oh, it's going to be coming out to be negative, unfortunately. Hmm. Because 36 minus 40 will be a negative number in this, which means that the root for this equation will be, I can straight away conclude from this, and this is what discriminant also is. It's good that you've got it over here. Look at this. What is this? This is nothing but b square, and this is nothing but 4 into a into c, right? तो अगर आपको ये डिस्क्रिमिनेंट बी स्क्वायर माइनस 4ac मिल गया है और वो एक नेगेटिव नंबर आ रहा है, तो इसका मतलब जो हमने, अगर आप याद करो, हमने पहले इसके बारे में बात करी है कि अगर हमारा डिस्क्रिमिनेंट जो है नेगेटिव होता है, तो क्या होता है कि हमारे जो रूट्स होंगे वो इमेजिनरी होंगे। तो इसका ये मतलब हुआ कि इस एक्सप्रेशन जो हमने क्वेश्चन में भी देखा है, एक्स स्क्वायर प्लस 6x प्लस 10, इसका ये मतलब हुआ कि ये एक्सप्रेशन का भी जो क्वाड्रेटिक होगा, वो क्वाड्रेटिक क्या होगा, उसका जो रूट्स होंगे वो इमेजिनरी होंगे। ठीक है, तो मुझे अब एक दूसरा क्वेश्चन आपको देना होगा। तो मैं एक दूसरा क्वेश्चन, एक इसी क्वेश्चन को थोड़ा सा मॉडिफाई करूंगा। सो आई पुट अ डिफरेंट नंबर, आई पुट एक्स स्क्वायर plus 6x, and instead of 10 I'll put 5, or I can put something which is less than 8. So if you want to figure out, and the same question I am going to ask you कि आप प्लीज आप ये बताएं कि इसका रूट क्या होगा। आप कहोगे माइनस बी प्लस माइनस बी स्क्वायर minus 4ac, right? You will say that the root of this expression is going to be a minus b plus minus b square minus 4ac. Upon 2a is very important, don't forget this. Now, when you do minus b plus minus b square minus 4ac, remember to take the values from a, b, c from the expression. So, which is, in this case, you have got the value of b as 6, which is minus 6. The value of a and c is also 1 and 5, so that is 36 minus 4 into 1 into 5. Okay, 36 minus 4 into 1 into 5. And now you will see you'll end up getting something which is very good. And what you end up getting in this case is 2 into 1 because a is what the value of your a is 1. One more thing I forgot to add. I think at some point I told you that roots cannot be, no, roots can be real. Real number can be both rational and irrational, right? Rational and irrational. So the discriminant that you get in this only tells you about real numbers. It tells you that कि जो आपका जो एक्सप्रेशन है उसका जो रूट होगा वो जो रूट है वो रियल होगा कि ये रियल नहीं होगा। ठीक है, आप रैशनल पे मत जाना, आप इरेशनल पे भी मत जाना, आप रियल नंबर के बारे में आप कंक्लूड करेंगे तो उसमें आपको ये पता चलेगा कि रियल नंबर वो केस में होगा जिस केस में हमने जो है रूट के बारे में बात करी है कि वो रूट का जो डिस्क्रिमिनेंट जो आई मीन जो रूट का जो फॉर्मूला है उसके अंदर एक ये ब्रैकेट स्क्वायर ब्रैकेट के अंदर डिस्क्रिमिनेंट हम निकालते हैं, वो एज लॉन्ग एज पॉजिटिव है तो हमारे पास रियल रूट्स होंगे, रैशनल हो या इरेशनल हो वो कुछ भी हो सकता है। तो small, I think I made somewhere I said something about rational irrational. So I'm just correcting myself in case you have not, if you have heard it before. All right, so let's come back to solving this. ये बन जाएगा आपका -6 बिकॉज -6 क्या था, -b, और -6 मतलब -b, उसके बाद आप जो इसमें आप सॉल्व करोगे डिस्क्रिमिनेंट तो ये बन जाएगा 36 और -20 आप यहाँ पे करोगे, फिर आपके पास आएगा 2, और आप इसको अगर सॉल्व करोगे तो -6 प्लस माइनस √16 अपॉन 2, तो ये बन जाएगा -6 प्लस -4/2। अब अगर इसको आप सॉल्व करोगे तो आपके यू विल गेट टू आंसर्स। द फर्स्ट आंसर इज -6 -4/2 which is -10/2। Second answer is -6 plus 4/2 which is -6 plus 4 is going to be -2. So -2/2 is going to be -1. Okay. And -6 minus 4/2 is going to be -10/2. -10/2 is going to be -5. So you have got two numbers which are the two numbers that you have got are -5 and -1, right? -5 and -1. These two numbers are the real numbers, and these are your real and distinct roots. Okay, real and distinct roots. Real and distinct. So that was one example where I have showed you how to use this formula. The formula, pardon my, bear with my handwriting, guys. I understand I'm trying to improve on this as I progress, but this is the root ka formula, which is what I replicated over here, -6 plus minus √36 minus 4 into 1 into 5 upon 2 into 1. So this is the formula that you have to just solve for figuring out the value of root. Okay. So far what we have done is we have figured out we have figured out what a discriminant is, which is b squared minus 4ac, and how it helps you in understanding the nature of roots, discriminant, and how it helps you in understanding the nature of roots. Remember the three scenarios. The discriminant can be a positive one, it can be a positive one, it can be a new zero, or or it can be a zero also, or positive, neutral. Actually, then it's zero. We should not call it neutral, or it could be negative, right? So now, if you know the value of discriminant, which is positive, neutral, or negative, you can figure out the nature of roots. And what is the nature of roots? In case of discriminant being positive, the nature of roots is going to be real and distinct. In case of discriminant being zero, the nature of roots are going to be real and repetitive. In case the discriminant is going to be negative, the nature of roots is going to be not real, which means imaginary, which is not possible. That's the idea, right? And the other idea is about roots. And for roots, we saw a beautiful formula, which is minus b. It's not beautiful, it's actually something hard to remember, perhaps. Minus b plus minus discriminant upon 2a. That's the idea. Remember the formula because I understand it's difficult to practice a couple of questions. But the good thing is you have simpler times for ahead, which means that I'll give you some of the ideas about roots, sum of roots and product of roots, और उस पे ही सारे क्वेश्चंस मोस्टली बनते हैं आपके आईपी मैट एग्जाम में. मोस्टली जो सारे क्वेश्चंस बनेंगे, मेजोरिटी ऑफ देम आर बेस्ड ऑन द कॉन्सेप्ट ऑफ रूट्स, जिसको हम कहते हैं कि बताएं आप व्हाट इज सम ऑफ रूट्स, व्हाट इज प्रोडक्ट ऑफ फ्रूट्स. और उसके जब आप सीख जाओगे इसके थ्योरी थ्योरी का पोर्शन, और जब आप ये सीख जाओगे कि हम रूट्स और का सम और रूट्स का प्रोडक्ट में क्या क्या चीज़ें हम कॉमन सेंस से कर सकते हैं और क्या क्या चीज़ें हम स्मार्टली कर सकते हैं, तो आपको समझ में आएगा कि इसके एप्लीकेशन क्वेश्चंस जबरदस्त बहुत तरीके के बनते हैं, और इसके जो क्वेश्चंस बनते हैं वो बहुत हाई लेवल पे ही बनते हैं. So those questions are your actual application questions. And this, my friends, is something that you are now ready. This is what is sort of being tested in exams. So far, what we have done is covering the basics and then covering the one more concept, but the application portion, which is what the next two videos I'll try and focus on, would be the first one of them would be on this concept, sum of roots and product of roots. And the next one would be on higher quadratic equation level questions. And that would mean the end of quadratic. In four videos, I have ended the quadratic, but hold on and please watch the remaining two also, inshallah. So thank you a lot for listening. I hope you take some value out of it and derive. Let me know if you do derive some value out of it. Thank you, guys.